Welcome everybody. Today we're going to talk about powers and exponents. It's going to be for our chapter 4, section 2. It's going to be our first part of our notes for this new chapter. Um, so let's go ahead and get started. First off, I want to do is talk about the actual numbers we're going to be dealing with this year, or this chapter. So we've got, let's just say that I have 2 to the 4th power, something like that. Two different parts of this number right here. We've got the big number, which we will end up calling the base, and then our second number up here, the little teeny tiny number that's always up and to the right, that's called the exponent. Okay, this entire thing together, these are called powers. Okay, so when we're talking about all these numbers, we're going to talk about powers. Now, really quickly, yesterday I had a big list for you guys that we went through, and we did something like 3 to the 5th, 3 to the 4th. We found a pattern. We finally ended up getting down to something like 3 to the 1st power. And remember, every time that anything was to the 1st power, it was always its own number. So 3 to the 1st power is going to be 3. The other important one we talked about was 3 to the 0 power. Any number that was to the 0 power is always 1. And we figured that out from our little pattern we talked about yesterday, because let's say 3 to the 5th power was 243, 3 to the 4th power was 81, 3 to the 3rd power was 27, 3 to the 2nd power, you all should know, is 9. So we divide by 3 to get that number, we divide by 3 to get that number, we divide by 3 to get that number. We divide by 3, we get 3 for our answer, and that's 3 to the 1st power. So then 3 to the 0 power, 3 divided by 3 would be 1. So we know that that becomes 1. So anytime we have 3 to the 0 power. For instance, if we have 5 to the 0 power, we're going to get 1 for our answer. If we have 15 to the 0 power, we're going to get 1 for our answer. If we have 1,152 to the 0 power, we're going to get 1 for our answer. So anytime it's to the 0 power, we get 1 for our final answer. Exponent form is the next that I'm going to talk about. When you write something in exponential form, that's 2 to the 3rd power, or even sometimes you have variables, which would be p to the 2nd power. Expanded form, and I think you guys talked about this a few years ago, is when we have like 2 to the 3rd power, you would do 2 times 2 times 2. You expand that 2 to the 3rd power out 3 times. Or for instance, this p to the 2nd power would be p times p. Okay? Standard form, okay, would be finally answering that. 2 to the 3rd power is 2 times 2 times 2, which would then be 8. Okay? We're not always going to just deal with regular whole numbers like the 2. Sometimes now that we're in algebra, let me get that back centered, we're going to have something like p plus 2, and this is all going to be the 3rd power. That means we're going to take this p plus 2, we're going to multiply it by p plus 2, we're going to multiply that by p plus 2. We're going to multiply it 1, 2, 3 different times. You can put multiplication signs in here if you want, if that helps you out, but you don't necessarily really need those. Okay? So let's work on a couple examples. Start off real easy. Example 1. Let's do 4 to the 2nd power. We know from up here the expanded form, 4 to the 2nd power is 4 times 4, which we know is 16. That should be a nice, real simple, easy one. Okay? Some more examples. Example, r to the 3rd power minus 3. Then we're going to say if r equals 2. We're going to end up taking this 2 and we're going to plug it in just like we did in the last chapter. So instead of saying r to the 3rd power, we're going to say 2 to the 3rd power minus 3. And this is where we're going to solve it. We need to know that 2 times 2 is 4, times another 2, because you need 3 of them, is 8. So what we really have is 8 minus 3, and then 8 minus 3 is 5. Okay? Here's another really, really important one that's going to be confusing for some people. If we have a negative 2 to the 2nd power, okay, this negative does not necessarily belong to the 2. We are only squaring this 2. So 2 squared is going to be 4. We actually bring down this negative sign to get negative 4. That's going to be different than if we have parenthesis negative 2 squared. This then means we're going to take our negative 2 and we're going to square the entire thing, which is a negative 2. Well, we know a negative times a negative is a positive 4. Okay? Very last example. if I have something like x, parenthesis, y plus z squared, when x equals 2, y equals a negative 2, and z equals 1. We're going to have to still plug these numbers in. So my x is going to be 2, y is going to be negative 2, z is going to be 1, so plus 1, and then we're going to square that. Okay? Still follow the order of operations. We need to do inside the parentheses first. So I'm going to bring down everything else I have not done. So this 2 I haven't done. Inside the parentheses is negative 2 plus 1, which is negative 1. That's still in the parentheses, and we're going to square it. Now, according to order of operations, please excuse my dear Aunt Sally. I've done everything in my parentheses. E, the exponents, the excuse part, is next. So before we can multiply this 2, I'm going to bring it down. I have to do negative 1 times negative 1. Well, negative times negative is positive. 1 times 1 is 1. So I really have 2 times 1 now because I just did that piece there. So 2 times 1 equals 2.